Hello, welcome to this video series on MDX for SQL developers. I'm Nasir Ali Mirza at DoSQLBI.com. Now the last item that we'll be covering is other commonly used MDX functions. We have few of them here. We'll see what is aggregate function, what is sum, count, min and max. There is out of box top count, bottom count. There are other variations of this top and bottom. There is top percent and bottom percent. We have a support for union, except, intersect that SQL developers have seen in the T-SQL, and then checking the existence. Then we see the current member, previous member, and next member usage, and something that's called as visual totals. There are large number of functions that are very powerful that are available in MDX queries, but I just thought to touch upon few that are commonly used. Let's switch to SQL Management Studio to see examples of all of these. In this example, we are using two functions. One is sum, another is aggregate. So we are defining two calculated members. In the first one, what we are doing is listing down all the product and what is the freight cost for them. So we named it as all freight cost. And in the second one, we just see only what is that cost for accessories, and then we make use of these two calculated members on axis 0. Let's run this query. So as we had also used calendar year on axis 1, so we are listing year from 2005 to 2010, and for each year we see what is the freight cost for all the products, and in the second column we see what is it only for accessories. Let's take a look at the count function now. In this example on the screen, we are counting the customers. So we say customer.children and simply take a total count of the customers. In the second named member, what we do is, if the customer count is greater than 0, that particular customer count with respect to the total, and we call that as customer base. We are formatting it with the percent format string. And now what we want to see is, I want to see state-wise, state province-wise, how many customers are in each province, but I want to see them as how much each province is contributing. I mean the customer base in each province, what is the percentage of that with respect to the total. You see, we are using this having clause also. In the having clause, we say where the customer base is greater than or equal to 0.01. Basically, we want to see only those provinces which have a customer base of at least 1% or above. Let's run this query. Now, you see here, we see the province names, and it shows us how is our customer base in each province. And you see, California is 24.0%, then England is 10.35, and so on. So just using this, a simple count function, we can create interesting result sets. After looking at count, we'll take another example in which we will see the use of min and max. So again, we are defining two members, one with the minimum. What we see is, we see the product and the internet sales amount. So what is the minimum amount of the internet sales amount across the products? Then we also see what is the maximum sales amount across the products. We name the first one as lowest value sale and the second one as highest value sale. Then we use these two named members on axis 0, and on axis 1 we put sales territory country.children. So basically we would want to see that in each country, what was the lowest sale that we made and what was the highest sale value that we made. Let's run this query. So here you see the output. For each country, we see the lowest sale that was ever made and the highest sale that was ever made. Again, very interesting information by using some, basic MDX functions. After looking at min and max, let's continue. In this one, we use top count function of MDX. Now let's see what the structure is like. We give it a tuple that returns its members, so this will return the stees, and we want to say that give me top 5 stees, and for deciding which is top, use this particular measure, which is reseller sales amount. So that we put on XS1. So in XS1, it's going to just give me the name of the stees, top 5 stees, and criteria would be sales amount. And on XS0, I'm putting that amount so that we can see what is the amount in those top 5 stees. Let's run this query. Now we see, reseller sales amount in Toronto is the highest one, then London, Seattle, Paris, and the last one. So this is how we can use the top count to just based on any particular measure as a criteria. After seeing the top count, let's see its opposite, which is a bottom count, and you can again expect that we are saying give me the bottom 5 stees based on reseller sales amount. Let's see what is the output. Now when we run this query, we see the value for all those stees is null. I mean, there has been no reseller sale in those stees. Now I want to see where I can add a criteria that filter out the stees where there is no sale and then show me the bottom count. I missed to mention that we also have this where clause so that we see this bottom count for bike sales. Now as we said that when the result of this query was, it just shows the bottom even when the sale was none. Let's see a different query. Now in this one, this is again the same query. All that we have done is we have added a filter. In this filter, what we are saying is the cities where reseller sales amount is greater than or equal to 1. So bottom count needs a set as a first parameter, but we are giving now a filtered set. So to ensure that at least whatever gets input to the bottom count function has 1 or more as a value. Now let's run this query. So the stees, the bottom 5 stees where we are selling bikes and sales amount is greater than or equal to 1, it gave us the bottom 5. So that's how we could use the bottom count function. After looking at top and bottom count, we'll see union, intersect, and except. I have some examples ready. Let's start with the union one. Sorry, the except one. So except, what it does is you have to give the 2 sets go as an input to that. So the first set what we have here is sales territory country dot children. So that means all the countries that we have in that attribute, and we give in the second set we give the member Australia. So what this is going to do is it will exclude what is in the second set from the first set and show the results. So when we run this query, what we expect to see is the result set excluding Australia. So you see here we have all the countries except for Australia. Then union, which is again very famous, SQL developers are used to for a long time. We again have country, but this time we are using Australia as a union. So let's run this query. Again, Australia is available here. Australia comes also as part of this set, but when it does the union, obviously nothing gets excluded. Now we can try something like, let's say Canada, for example. Instead of children, I mention here Canada, and then I run this query for a union. So I see union Canada and Australia. And the last one in this is intersect. So what it does is what intersects between set 1 and set 2. So in this case, again, this set has Australia in it, and second, there is an Australia as well. Now when we run this query, the intersect would give us just one row, because that is the only member that intersects between the two sets. After looking at union, intersect, and except, we'll take a look at example related to current member, previous member, and next member. I'll directly jump to the example. This current member, previous member, and next member is a very powerful thing that we can use in various contexts. We saw in the previous examples that how we could build some interesting result sets based on this. Now let me kind of give a quick explanation what we are doing, and we'll see the result set as well. We are again defining 1, 2, 3 named members. The first one we set current member, then member as a previous member, and next member as a next member. All that we do is we just say sales territory dot current member, and then we just take the sales amount. The format string we use currency in all the three. In the second one we say previous member, and in the third one we say next member. Then what we are doing is we are just using this measure, that is reseller sales amount, and using the three named members, current member, previous member, and the next member. Then we are also on the XS1 listing down the country members. Let's run this query. Created this example to give you a clear feel what does it mean. So what we are seeing here is this is my list. This is the list of countries that I have. So for United Kingdom, the previous member is Germany, and Canada is the next member for United Kingdom. Let's see what we are doing. Now here, for United Kingdom, if the sales value is this, its previous member's sales value is this, and then its next member's sales value is this. Now see for United Kingdom. First column is reseller sales amount, then current member sales amount. So current member should match these two because that's what the current member is. And then the previous member for United Kingdom is Germany. So when I see this previous member for United Kingdom, this previous member value should match the value of Germany. So here is 1983988, 1983988. Now for United Kingdom again, the next member which is Canada, the reseller sales amount should be this one. So this reseller sales amount 14377,925 is what is matching here. Now look at the first one. First one is France. We see the previous member value as null because there is no previous member for that. And as understandable, the last member is Australia. There is no next member. So that's why for the next member we see this null. This is just to kind of give you a feel of what we can pull up with the current member, previous member, and next member. And while creating some interesting queries and manipulation, you can use it in those particular contexts. Let's see one example, quick example that how we will make use of this current member. Now in this query, we say we are just listing down the team size in increasing order. Defining a member with the name team size, and I'm using the employee user-defined hierarchy, and then I say current member. But about the current member, I have a way to just use the siblings count. So which means what are the number of members at that level. So that is the team size, and I see this team size. I put it as on XS1 and on XS0, and on XS1 I simply list down the team members. I also use the order. Now this order helps me that I want to order them as per the team size, and that ordering I want to be done on the ascending order. You'll see ascending order, there is another way I can use binary ascending order. So that's what this BASC is. Let's run this query. So this gives me the name of the employee and the team size. So this is one at that level, this one has 2, and so on and so forth. So you see, as you go down, the maximum team sizes are, the sibling counts is 24. So this current member, previous member, and next member, depending upon the situation and the query you are writing, they are very, again, powerful things in MDX. Next, we'll take a look at something called as visual totals. Before we actually see that, let's see an example. Now, in this simple example, I'm referring to product category, the all member, and then accessories and clothing. When I run this, I see the value for accessories, I see the value for clothing. But all products, this value here is not the sum of these two. It is rather the sum of all the product category. Now, sometimes we have a need that whatever we list down as the members, instead of that all total, which also includes the products that are not listed, we want to see only the sum of the items that are listed on the screen. Listed as an, that is the output of the query. So that is where visual totals help us. So to remember about visual totals is, it can be used only with one dimension. Now what we are doing here is we are using visual totals where I say category and subcategory. Let's run this query. It gives an error. The visual total function may only be called with a single hierarchy set parameters. So we have here multiple hierarchies that are used in the tuple. After looking at the visual totals, we have the last one remaining, which is the exists function. Let's see this example, what we do. Exists, we have to give two sets. So what it does is, it just sees from the set 1, what is that exists in the second set. Only those it displays. Now what we are doing here is, we want to see the employees that belong to department research and development, and the employees that belong to finance department. Let's run this query. So let's see how many rows we got. We got about 19 rows. Now to just make sure that it is really filtering out, what we can do is comment out the second one and rerun this query, and you can see the result set itself looks smaller and we have only 8 rows out. So the exists, it just sees the first set and what exists out of the set members in the second set, and it shows only those that exist in the second set also from the first set. We have some other interesting examples of this. In this example, we are seeing customers of a particular city. So we say customers as a first set for the exists, and the second one we say where the state province is California. So when we run this query, it gives me the customers which belong to state province California, about 4,445 rows. There is a variation of the exists, how we can use that. Let me show you that example as well. This again exactly the same query where I say first set is customer members, the second is California, and then we give a third parameter within quotes as the major group name. So we say internet sales. Now whatever would be the output, it would also check that they should have at least a row in this particular major group. That means we can say customers of a particular city with internet sales. So we get that output as well. The last example for the exists function is that we are saying in the first set again the customer members, and then in the second set we say the customers that belong to California and who have bought the product clothing. So let's run this query. Now we see there are about 1,509 customers that belong to California and who have bought a product clothing as an internet sales. This brings us to the last example. Let's switch back to our presentation. We covered some of the commonly used MDX functions. We saw aggregate, sum, count, min, max, top count, top percent, and something which SQL developers are quite familiar with: union, except, intersect. Exists, again, a powerful one: current member, previous member, and next member. And then the visual totals as well. This brings the end of this series that we started as MDX for SQL developers. The approach taken in this series was to make it conceptually easy for someone who has a background in SQL, T-SQL development, and how they can correlate to when they start writing the MDX queries. I hope these presentations were helpful. Feel free to share your feedback, and I appreciate your time in just watching these presentations. I'm Nasser Ali Mirza at DoSQLBI.com.